Hi there everyone and welcome back to the channel. Some of you out there will already know what this bit of equipment on the bench beside me means. It's time for another battery testing video, and it's a pretty exciting one because we are going to be looking at the brand new Tattu R-Line V6. We're going to be looking at two 6S packs, the 1600 and the 1480 mAh, and putting them through their paces. Tattu seem pretty confident in these packs because they have sent me 4 of each to test. So we're going to be looking at not just the raw performance of these new batteries, but also the variation pack to pack to see how good Tattu are with their manufacturing tolerances and how consistent the packs are. We're also going to be seeing if these new packs are able to challenge the SMC Racing 1600 and 1400, which are currently sitting at the top of my leaderboard. Something tells me that Tattu wouldn't have sent me these packs if they didn't think they had at least a shot of beating them. So let's see if it turns out that they can. As well as just doing all the normal tests like looking at capacity, energy density, power density, I'm also going to be doing some thermography in this video so that we can look at how hot these packs get when you push them to their absolute limits. It's going to be an awesome video. Can't wait to dive into it. Let's not waste any more time. Tattu sent me these packs to test, but I didn't receive any payment or other type of compensation for making this video, and I never do for product reviews. So if you'd like to support me to make more videos like this for everyone in the FPV community, there's a couple of ways to do it. If you'd like to pick up some Tattu R-Line V6 packs for yourself, then check out the links down in the video description. They're affiliate links, which means if you click through and make a purchase, the retailer will give me a small commission, help support the channel, and it doesn't cost you anything. The other way is to join up on my Patreon, and there are links to that down in the video description as well, and you'll get access to all of the raw data from this battery testing and all of the battery, motor and prop testing that I've done on this channel throughout the years in the past. And it's a treasure trove of independent testing data which just isn't really available anywhere else in FPV. So if that interests you, then check out my Patreon down in the video description. Now on with the video. Let's start by just taking a look at the physical packs on the bench. And the first thing I noticed is that with these new V6 packs, you get a choice of 2 different shapes of pack. You can have a stick pack, which is slightly longer, or a square pack, which is slightly sort of shorter and fatter. The stick pack is about 38mm by 78mm, and the thickness of the 1480 is about 37mm. If you go to the square, the pack's about 5mm wider and 6mm shorter, so you're looking at 43 by about 72. For the 1600, it's exactly the same shape, so the same kind of width and length, but the thickness is a bit more. So for the 1600, you're looking at a thickness of about 40mm compared to the 1480, which is more like 36.5. So you're going to choose the shape of the pack based on the type of drone that you're flying. If you've got a shorter top plate, you might prefer the square. If you've got a longer top plate, you might prefer the stick. I've got the 1480 and 1550 V5s for comparison now. And if we take a look at the 1480, the V5 versus the new 1480 V6, it's the same shape of cell, so the same width and the same length, but the height's vastly different. You can see that the new V6 is about 20% thinner than the old 1480 V5, and that has a big impact on the weight. The 1480 V5 was 238 grams. The 1480 V6 is 222 grams, so a pretty big weight saving. If we then look at the 1550 V5, which is the closest I have to the 1600, the 1550 V5 comes in at 255 grams. The 1600 V6 comes in at just 242 grams. So again, a pretty substantial weight saving. And in case you're wondering, the square and the stick cells weigh pretty much exactly the same. We've got 222.7 for the 1480 stick versus 221.7 for the square. And for the 1600, it's 241.8 versus 241. So there's almost no difference between the stick and the square in terms of weight, and there's probably more difference pack to pack than there is between the different shapes here. Before we dive into the results, let me take you through the test methodology. Here we're going to be doing 2 types of test: a constant power discharge test to measure the capacity of the pack and its energy density, and a burst power test where we're looking at the maximum power that the pack can possibly supply under the most extreme conditions. Let's start by looking at the constant power discharge test. So here's a live recording of a constant power discharge test. And here I've overlaid the thermal imagery from the thermal camera on top of the test chart, so you can kind of see everything happening all at the same time. Initially, you can see that the voltage drops very quickly from 25.2 down to about 24.5 volts, and then begins to gradually descend as we discharge the pack. We're discharging the pack at 15 C, which means that we will empty the whole pack in just about 4 minutes. Already at 15 C, you can see the battery is starting to warm up. We're up to about 29 degrees on the pack now. And if you're wondering, why can I read the text on the battery? That's a clever composite image thing that FLIR do with their thermal cameras. They overlay a visible light image with the thermal image so you can kind of see the shapes, but the colors indicate the temperature. It's pretty cool. As we discharge the pack over about 5 watt hours or so, you can see that we get a little kind of hump and a dip. This is very typical of standard LiPo packs. You don't tend to see this so much with lithium high volt, but you do see it with LiPo. You get this little hump, and now we're into kind of the main body of the discharge curve. And the pack is kind of gradually warming up as we're doing this discharge, but you can see that overall the connector is staying pretty cool. So most of the temperature that we're seeing is actually building up in the cells of the battery itself. And we're not getting to any sort of concerning temperature, only up to about 30 degrees or so during this test. Obviously, if you discharge the pack a lot faster than 15 C, it will get a lot hotter, as we'll see in a moment. In terms of the ambient temperature in which we're doing this testing, I do all of my battery testing in a temperature controlled 24 degrees. So whether it's winter or summer, I test all the batteries at 24 Celsius. And the reason that's important is because battery performance can change a huge amount depending on the temperature at which you do the test. So doing the test at a hotter temperature or a colder temperature is going to make a big difference as to how the battery is going to perform, how much energy you're going to get out of it, and how it's going to perform under the burst testing as well. As we continue to kind of discharge the pack, we're doing it at constant power. And that means that as the voltage of the pack falls, we demand a bit more current from the battery to compensate. And a constant power discharge test is really equivalent to what you would get if you were doing kind of a freestyle flight at a constant speed, where you're just drawing always the same amount of power out of the pack. And as the voltage sags a bit through the life of the battery, you increase the throttle to compensate. That gives you a kind of constant power test. And for a 1480 pack like this, the power that we're discharging it at is just around 500 watts, because that's 22.2 volts times 1.48 amp hours times 15 C. Now we're getting kind of into the discharge. We're down to 22 volts. The pack's up to about 40 degrees. And as well as just having the pack sitting on the bench, you can't see in the thermal image, but just off screen, there's a fan that's blowing gently on the pack, just to kind of produce the same kind of airflow that you would see if you had this battery mounted on a quad and you were flying it through the air. It's not a howling gale. It's not loads and loads of forced cooling, but it is just a little bit. And this becomes important when we're doing burst power testing, because without a little bit of cooling airflow, certain things can get really, really very hot, and I want to kind of avoid that in the test, as you'll see. So we have a little bit of forced airflow. Now we're getting to the end of the discharge for this pack, and you can see that the voltage is starting to dip and begins to dive down. Once you're below about 21 volts, the pack has very, very little capacity left, and the voltage just falls off a cliff down to 18.6 volts, 3.1 volts per cell, which is where I've configured the test to stop. You can see at the end of the test, we have a battery temperature of just about 49 degrees, and we got 1.485 amp hours out of this pack, a little bit more than the stated capacity of 1.48, which is really good, especially when we're discharging the pack at 15 C. If I turn the pack on its side, you can see that we do have the side of the pack getting even a little bit warmer than kind of the top. Depending on exactly what angle you're looking at, you can kind of find the hottest part of the pack. But you can see the middle cell is getting up to just around 51 after this whole 15C discharge test. And that is a perfectly safe temperature for a battery to be at. so no need to worry. All right, so now for something even more exciting. This is the burst discharge test. And we're going to start the burst discharge test by discharging the pack at 15C at constant current. Now for a 1.6 amp hour pack, which is what we're testing here, that's 24 amps or about 560 watts when the battery is pretty close to fully charged. The reason that we do this discharge at 15C is to condition the pack, to allow the cells to warm up and to get the chemistry into the state it would be in once the pack is flying on a drone. Obviously, it's not really a fair test to just hit the pack with all the current from cold, because you never do that in reality. You're going to fly the pack, warm it up, and then do a punch out where you're going to require the battery to deliver a lot of current. After the pack has been discharged for 48 seconds at 15C, it is 80% full, and that's when we start the burst test. And you can see that the battery voltage suddenly dips as we start the burst. Here, the current that we're demanding from the battery ramps up at 2C per second, and you can watch the power rise on the live view on the right of the screen. Remember that my test equipment is rated for 2 kilowatts, which means that I have voided my warranty. But we're going to keep going and keep drawing more and more power. And you can see as we're crossing that 2 kilowatts, actually the connector is what's getting really, really hot. Passing 75 degrees now. It's going to get a lot hotter than that. The 1600 milliamp hour pack is actually now delivering 3 kilowatts through my test equipment, or 50% over its warranty rating. But finally it gives out. The battery voltage drops below 18 volts and the connector peaked at just about 120 degrees Celsius. And that is with a little bit of forced airflow from the fan. The battery pack itself gets to between 70 and 75 degrees during this test, which is hot, but not too hot. And so that is what it looks like when you burst test a Tattu R-Line V6. So I guess it turns out you can pull about 150 amps through an XT60 connector for a little while at least, but you probably shouldn't unless you have really good cooling, because I was pretty shocked at how hot that connector got. And if I didn't have any cooling, I'm worried that it would have melted or dissoldered itself, either of which could have been very, very bad. So I guess I should have been paying attention to how hot the XT60 was getting in some of my previous testing, but I guess we live and learn. At least now I know that I definitely need that fan if I'm testing any powerful packs in the future. So now you've seen how I collect all the test data and what it looks like when I push a pack to its limits. Let's take a look at the results. Let's start by taking a look at the rated capacity of the packs versus the tested capacity. And in my capacity test, I'm discharging the pack at 15C. So that's like representative of what we do in a typical FPV flight. And here we can see that actually Tattu do really well here. All of the packs deliver at least their rated capacity under this test. And that's not very common. When you discharge a pack at 15C, that's a lot faster than typically you would discharge a pack when you are testing it to determine its capacity in like a factory. Normally you discharge a pack at maybe 1C, and then that would give you the capacity of the cells that you'd print on the pack. So if we discharge at 15C and we still get more than the capacity that's printed on the pack, that indicates that Tattu are correctly rating these packs for the type of application that we're going to be using them for. Of course, as pilots, we don't just care about capacity, we also care about voltage and weight. So let's take a look at the voltage sag for these new V6 packs now. And again, we're comparing against V5. And you can see that there are basically two very clear groups of lines on this chart of voltage versus capacity. The upper line is V6 and the lower line is V5. And pretty much across the entire discharge curve, the V6 packs have about 0.4 volts less voltage sag than what we saw with V5. If we take into account the battery capacity, the voltage of the pack during discharge, and the battery weight, we get a measure of energy density, which is the amount of energy stored in the battery in watt-hours per gram of battery weight. And here we're comparing Tattu R-Line V6 against R-Line V5, and you can see that we get a pretty sizable uplift in this new generation. We're looking at anywhere from 11 to 15% more energy density, comparing between the 1480 V5 and the 1480 V6, and anywhere from about 14 to 18% better energy density when comparing between the V5 1550 and the V6 1600 packs. All right, so now for the really interesting comparison. Here we're pitting the Tattu R-Line V6 packs against the best batteries I have ever tested up until now, which are the SMC Racing 1400 and 1600 mAh packs. And overall, the SMC Racing come in at about 0.155 watt hours per gram. The Tattu R-Line V6 come in anywhere from 0.153 to maybe 0.156. So overall, on average, they're about 1% behind, but it's very, very close between these two batteries. And I think it's pretty much going to come down to pricing and availability if you're choosing between these packs based on energy density. But don't decide just yet, because we still have to look at the results from the power testing. Here we're looking at the results for the maximum current that the cells can provide when discharged from 80% full down to 3.3 volts per cell. And this is using my standard burst test ramp of 2C per second. Comparing the 1480 V5 packs to the 1480 V6 packs, you can see that Tattu have achieved a significant uplift of anywhere from 19 to 25% more current during the burst test than we got from the V5s. When we're looking at the 1550 V5s versus the 1600 V6s, again we see a big improvement, anywhere from 28 to 33%. And the new V6 1600s actually deliver between 24 and 29% more current than the old V5 1800 packs, which are significantly bigger and heavier. So Tattu have done a really good job here improving the burst current performance of the pack. You can also see how that equates to C rate. Here we're just dividing the maximum current by the rated capacity to get the C rate, or I call it the Rosser C rate because obviously my test is going to be different to the manufacturer's test. The important thing is that these are all comparable numbers, and we're getting anywhere from 90 to close to 100 on the Rosser C rate for these new V6 packs. For those of you that prefer to see the maximum power in watts rather than the maximum current in amps, this chart shows you the same information as the previous chart, just with the figures converted to watts. So the 1480 V6 packs deliver anywhere from 2650 to 2750 watts under the burst test, and the 1600 mAh V6 packs deliver anywhere from 2950 watts to 3100 watts. And of course, because it's the same data as the previous chart, we get the same uplifts compared to V5. When we take the weight of the pack into account, we get the power density in watts of power delivered per gram of battery weight. And here we can see the uplift is even bigger than we got with just the raw power figures, because these new V6 packs are a little bit lighter. The uplift from the 1480 V5 to the 1480 V6 is anywhere from 28 to 34%, depending on the pack. And the uplift from the 1550 V5 to the 1600 V6 is anywhere from 36 to 41%. Compared to the V5 1800 mAh, we see an uplift of 47 to 53%. Again, that's comparing to the 1600 mAh V5. So a huge improvement in power density. Now let's put the new Tattu R-Line V6 up against the best packs I've ever tested before for power density, which are the SMC Racing 1400 and 1600. Here we can see that the SMC Racing have a power density on average of about 12.7 watts per gram. And the Tattu R-Line V6 get tantalizingly close to that figure. Some of the packs are getting up there, 12.7 watts per gram. Some of them are just a little bit lower. On average, the Tattu R-Line V6 is only about 1 to 2% behind the SMC Racing packs in terms of power density. And I would say for all intents and purposes, these packs are probably pretty equivalent in terms of power density, particularly when you take into account pack-to-pack variation and variation due to temperature or age of the pack. What I would say is that you're going to choose between the SMC Racing and the Tattu R-Line V6 based on price and availability, because the performance is very, very similar. So now that we've looked at all of the test results and data, it's time for me to give you my thoughts and conclusions on these new Tattu R-Line V6 packs, the 1480 and the 1600. And overall, I think that Tattu have made a really significant step forward and an improvement with the new V6 lineup compared to what we had with V5. We're looking at double-digit improvements in energy density and power density improvements of like 30%, which is enormous compared to just one generation ago with V5. So that's really impressive. And these packs are now going toe-to-toe with the very best packs that I've ever tested before, which is really impressive. pretty much you're going to pick, if you are only interested in performance, you're going to pick between the SMC Racing and the new Tattu R-Line V6 based on price and availability where you are. And I also really like that Tattu are offering two different shapes of the new V6 packs. You can get the stick or the square. There's not a huge difference in the shape between the two, but you might just find that one shape or other fits better with the shape of the top plate on your quad or how you want to mount the pack. So that's really nice to see, and that's not something that I've seen offered by many other manufacturers. So it's nice to see them taking that extra effort to give us some more choice over exactly what shape of battery is going to be best for the type of quad that we want to fly. When you're considering whether to buy the 1480 or the 1600, just remember that these new packs are a lot lighter than the previous generation. So if you previously were happy with a 1480 V5, you probably want to move up to a 1600 V6 if you want a pack of the same weight. Otherwise, you're going to buy a 1480 V6 and find the pack's quite a bit lighter. You might want a lighter pack, you might want a bit more flight time, a bit more power for the same weight. Just bear that in mind when you're choosing which one to buy. And of course, there are links down in the video description to where you can pick up all of these packs today. And they are affiliate links, which means that if you click on them, it does help support the channel. The retailer will make a small donation to help me make more videos like this for you and everyone else in the FPV community. It won't cost you anything, so please do use those links if you possibly can. That's all I have for you for today. So until next time, I wish you all very, very happy flying.